All right, thanks for coming to my talk. Thanks for the introduction as well. That's true. I'm Jorge Bejar. Let's do some quick presentation of myself. Working at WiWorks, but also collaborating during this day, and especially in this project with FutureWay. In this talk, I'm gonna introduce you and do a little demo about a pure Rust Explorer for open source LLMs models. Is one application that we hope that improve the way we work and test and discover these kind of models and enable more people to be in this world. I have to say that I'm not an expert in LLMs, AI. I mean, if you hear my biography, it doesn't much about that. But this is the beauty of this application. We are building this application for people like me that are trying to get more involved. We need easier ways to test that models and to play with, I don't know, prompt engineering, let's say something. If you want to, I'm curious, I'm enthusiastic to learn about that. So these kind of applications, yeah, our aim is close the gap and introduce more and more people. In this talk also we will have the collaboration, and there is a specific part that is going to be presented by Haidai from the Wasm Edge team. He has already a talk before, but because Moxin is it's using that product, so it's a collaboration we have here on stage, but also for the application, right? By the way, my English is not perfect. If you have to interrupt in order to it doesn't sound clear, please let me know. Okay, what is Moxin? Let me check the time. Sorry, I should do this before. I already introduced it. It's a little application. I'm going to do two demos, but the first one is to introduce it. But yeah, we will start doing that demo and little explanation. Then we will discuss the Moxin implementation, which has a series of components that are working in combination. We will do another one demo, but with a use case, as I explained, like how a user will use this application to take advantage of the models, and of course, closing notes. But yeah, let's go with this model. Moxin is an application like this one. Let's do a quick demo. No, let's explain a little more. Sorry. It's mainly an application to explore, to discover, to find out the open source model. And it's important to say that we are working with open source. It's amazing how the number of options that we have right now, the number of options that all the time are appearing, showing up in the open source space. So yeah, keeping track of that, navigating that much information, it's important to have better tools to do that. So yeah, we want to have an application to discover things. It's important also to run the models with your hardware, your local machine. That's we want to enable the edge development. I learned the term today from the other talks, but yeah, it's a way we as developers of bigger systems that we, for example, developing a web development system, a web application. Let's say if you want to test to do one component with these LLM models, it's important that you have the chance to play with that with your own hardware without much trouble. So, and luckily there are a lot of models. It's something that I learned working in this project, that you can actually run with a normal developer computer. So that's super cool. Also, yeah, we want also to offer with this application a familiar and approachable way to try out different prompts, to do prompt engineering in a more agile way. And of course, we can think on more cases like a RAG or something like that. But we are focusing right now in having the best experience from prompts. And we have the MVP that is still growing. The application I'm going to show you now is just in the first version. MVP is nothing we are about to publish it, but we are kind of wrapping up the effort, but good enough to present today. So let's play with him. Let me check if we are fine. Cargo run. I didn't say that this is fully implemented with Rust. But we are going to speak about that in a few minutes. That's the reason I'm using cargo, because this is from Rust. Okay, so it's starting. Here we go. This is our application. You have like an initial, it's probably better tailored to, okay. Not sure if the font is right. I mean, this is not web. This is a native application. This is a desktop application. The beauty is that we are using in our stack technology that is cross-platform, so they can run also on Linux. And we didn't have a lot testing on Mac, in Windows, but in theory it should work, or we are closer to have that working there. I'm going to explain that in a while. And yeah, primarily it's a way to explore different models. You have links to the developer, to the Hugging Face page. A lot of the information that we have in our database is coming from Hugging Face models that are published there. We do an effort to curate the information and to put metadata, description, more information about the models. So yeah, that's part of the story. You can, of course, you can, let's say, you can explore more options. There are, yeah, this is a database of options, YAML versions. I mean, you can query by names, the proper information. And of course, and I think this is a good feature. I know there are products that already have this, but it's important to have a way to download the models, because we want to test in this computer. So yeah, you have implemented a downloader manager. I'm not going to download this large file right now, but you have the basic functionality to download. I'm just going to interrupt everything. You have a section that you have your library of downloaded models. In a fast presentation, I think the designers do a good job. Probably this is the more tailored size for the application. You can have more information, linked to the model in Hugging Face as well, a way to delete them. I mean, I want to preserve them because of the demo, but yeah, just a way to see your models. You can also see the real location. But the most interesting part is the chat itself. Yes, it's our interface to chat with the models. So I can say, sorry if the font is quite, let me know if you want. How far is Montevideo from Delft? I didn't say I'm coming from Montevideo, Uruguay. So I want you to have some, you can read it? Or, yeah. I can tweak the application to be a bigger, but I can read. No, but this is bad. This is wrong. This is wrong. This is not. I mean, one of the things that I want to present about the beauty of the application. This is probably not a good model for this question. In this computer, I can run models like this one, probably bigger. It's just a struggle because of the hardware. That's a limitation. So I will gonna use the Llama with it's a bit bigger. How far? And I will let you know if I agree with the response. Far is Montevideo from Delft? It takes some seconds because you are running in this computer. And I think that's more accurate. I think it's farthest. I think it's more like 8,000 kilometers. But you can retry. I think it's closer than that instance. It's funny because in all the presentation in this track, the model is kind of, yeah, it's imperfect. you can make fun of that. But let's try. For example, the formatting for us is important, so we invested some time on Markdown formatting, which is important. So let's try something like how you would fly from Montevideo to fly between the cities. Use the context from the previous one. Which scales? I forget the markdown. You have some options, blah, 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 blah. Let me interrupt it. How old? Let's edit this one. Please format the answer in, markdown. The markdown formatting depends a lot of the model, but we do our best to render it in the proper way. It's using some formatting. I have to say that I used the first option. Oh, now it was broken for some reason. Now, I think it works a bit better with the Mistral one, which is a better model, I would say. Because it's bigger. It's not a very informed decision, but yeah, for people like me that is not an expert, it's good to have a grasp of the difference between the sizes of the models and the difference on how they respond. This kind of application helps really a lot to do that. Wow. No, but you can spot the error. I forgot the first, I mean, there is no context, right? That was a CG error. How do you find between Montevideo and Delft? Try again. I think it's looking better. Connections is the word in English that I think that better works. I'm gonna stop trying in a while. Sorry if I'm boring you. This is connection, right? I see connection is a better way. It's a better word for that. Now it's showing up a better formatting. Now it's noticing the bold and sometimes it gives you some headings that is probably more noticeable, but yeah. And yeah, it tries to do, but again, I mean, the idea is we are trying to build, for now is what we have, but it's a fancy way or comfortable way to try different prompts and quickly switch between the models and see what happens. This is local. Only local. Only local for now. Yeah, it's only local. You have to download the models. This is our downloaded models. And here we can actually navigate and download models to try out. Thanks for the question. It's a good one. Okay, get back to the presentation. Whoop. What is my presentation? I miss it. Oh, yeah, here. My bad. It was the demo, and everything that we implement is open source. Again, we are just starting. This has literally some weeks of development, no more than that, and a small team. I mean, there is collaboration between different companies on the founding and the support from the future way. But yeah, I'm going to invite you again at the end of the talk, but yeah, you can check it out, the code at that repo. Let's speak a little bit about the architecture. Everything that you say, almost everything runs locally in your computer. The machine itself is a desktop application. It has two main components. One is both in Rust. One is the front end. That is all the user interface. We are going to expand a little bit on this talk. I mean, this is not the application track, I know, but it's kind of, I'm like an imposter. I'm going to speak about front-end application a little bit. Sorry about that. And also the back-end, which is the part that actually interacts with the LLMs and WASM runtime has, the main particular, most of the work there. And also, we rely in an external database, which is in the internet. All the information that we are displaying in the discovery section is taken from just a regular web server, JSON API. We communicate with them. So now I invite, a little bit, why Rust? And after that, it's going to be presented. It's important to me to say why we choose Rust to do that. Because also the front end, but yeah, it's just repeating something that, I know this event is happening co-host with the Rust and Len, so it's not a surprise that we are also promoting Rust here, but yeah, there are many reasons that people are more and more using Rust, growing the interest overall. That the performance, the safety, the cross-platform compilation is something that we plan to take fully advantage. Moxin, the one thing is, we can run in every operating system. That is very important if we want to take more advantage of our own hardware. So this ability of Rust to cross-compile is super handy. The interoperability of Rust is very good, and we will have a good example of that with the LlamaEdge. Because there is interoperability with other technology that you actually use more often in the AI world, like Python, let's say that. But Rust has very good feature on interoperability with different stacks. And the productivity as well, this I think is a good example that we actually were able to produce this product in record time. And the availability of crates, which are libraries in Rust, for many problems and domains are super good as well. We will discuss a little bit why Rust from the front end, which is probably a more exoteric decision. But yeah, a little bit about that. We have this phrase, it's probably not important. Let's use the time for the Moxin version. Thanks, Heidi.
Okay, it's me again. So I want to, explain how the backend works, and I will do it very high level. So the Moxin backend, the Rust part, actually is two parts. One is the Rust part to handle all of the requests from the front end, and the Wasm part is actually to execute the model itself. So let's go through the Rust part first. So the main repo is that we have a pre-built Wasm file. The reason is that it's a totally black box for the backend, and it is also compiled from the Rust code. But when you use this Wasm file, you can always do the updates over air, and every time you want to add a new model or add a new template, lots of different upgrades, you can just replace the Wasm file directly. And you don't need to change anything about your backend. The only thing you need to do is just replace the Wasm file itself. And then the main repo will retrieve the request from the front end, and then it will dispatch the request into the command handler. Is just the photo you see in the previous slide. And the command handler actually is only two different behavior here. One is the model management, one is the model interaction. The first is you can download, you can delete the model, just demoed before. And the other thing is that you can decide the model is load or is eject. And you can always run or stop the chat just like the demo. And we also have a work in progress part is that we want to enable that you can run and stop a local LLM server, so you can do more than just chat. Okay, so this is the overview, and it's very complicated, but the main idea is the bone. You only need to register 3 important functions. One is the get input, one is the push token, the other is return token error. You need to define these 3 functions in your backend and register it into our WasmEdge runtime to make sure that the Wasm application can use these 3 functions to interact with your backend. That's all you need to do the communication. The only 3 public API. So that's the first part. And also, you will have lots of different metadata or configuration you have to set. That's just from the setup of your backend to spawn a new thread to handle the Wasm runner. Okay, so let's go to the Wasm part. The Wasm part actually is just built from this project. So you can go to this link and build by yourself. You can. It's a Rust project also, so you can just replace anything you want. And actually, if you use standalone Wasm runtime to execute this file, actually it's just the demo I made in the morning presentation. Actually, it's just a CLI chat bot, and you can communicate with it. So the important thing is that because it's a CLI, so all you need to do is to handle the I/O part. So the get input actually is handle the keyboard input, and the return output is actually the token, the model inference, and back to you. Once there is any error, for example, is segmented fault, or the context is full, or lots of different errors, then it will trigger that return token error from Wasm to your backend callback function. So that's how the Rust part, Rust backend, and the Wasm application to interact. Yep. So that's my super fast overview of it. Yeah.
Thank you, man. That's because he's the expert of this part. So can you hear me? Yeah. Again, it was a collaboration between one team. I'm more involved in the front-end implementation, and the team from the company that is coming, Haidai, is more actually working in the backend part. So it was awesome that he presented this part. About the front end, let's speak a little more about why Rust and why Rust from the front end. Because yeah, the backend I think is probably more people are using Rust, and it's a big adoption for the backend. But the development is still, I mean, the ecosystem is a bit rough, as I write in this slide. There were some talks related with the application development state of the art on Rust in the door track. So just a super recap of that. Yeah, it's not fully clear what tools are available or how are the state of them, if they are still on development, is there a prototype, or which one are production ready, which are not many, or recommended. There is a lot of, there is not big winners that you can say you have to use this specific platform. Also, there is a chronic, I say, lack of examples and proper documentation. So we are part of, or even examples. I see Moxin now could be a good example of how you can build a user interface application with Rust. And we expect to have more and more people doing more examples, but yeah, we are still scratching the surface on that force. And there is also friendly competition between crates, which are libraries or frameworks, but sometimes there are lack of coordination. They have overlapping features, hard to integrate them. But there is hope, because some people are thinking hard on that problems, and that lacks on the community, on the ecosystem. So today I'm going to speak just a brief presentation about two things. The Rubius initiative, which is an umbrella community effort that is aiming to put some coordination, let's say, or sanity on the application development ecosystem for Rust. Everything that we use for Moxin is coming from projects that are under this umbrella initiative, so it's important to remark them. And we are using for Moxin the Makepad framework, which is actually the framework we choose. And we also are collaborating with the Makepad team, active developers there. So by making Moxin, we are improving Makepad. And that's part of the goal. It's part of the goal also to keep growing all the tools that we have for the application development. And I feel we are not too far to have battle tested, let's say beta things that you can actually recommend to a friend to use to do a web application with Rust. We are reaching that point, I would say. But again, Moxin is an example of something that is working, and we are pretty close to publish if you want. And you can download it, and it's going to work. Okay, I already speak about the reviews, but just to remember, you can check out the web explaining this project. It's also including more frameworks. It's not only Makepad. There is another things that you can try out. Right after this talk, we have Jonathan speaking of Dioxus, which is another fantastic framework that is part of this initiative. But yeah, let's speak a little bit about Makepad because it's the main software we are using for the front end in Moxin. Makepad is offering us, I mean, it's quite unique. Specifically, the second point is quite unique, the approach for the user interface development. I mean, commonly, the most modern options right now, you can think in Flutter, React, whatever, coming from the web or from the cross-platform initiatives, that they are all based on the reactivity model, declarative style. In Makepad, you have like a more low-level approach because they want to show up or to enable developers to make more use of the hardware, let's say the GPU, the shaders, that part. So it's a combination between the retaining mode, which is the declarative style that you have, for example, in React, JavaScript, but also in immediate mode, which is more like draw a statement like you will do when you work with the shaders or that kind of thing. So you will see some examples when I show some code, but it's fantastic. We are still making our heads to take the best of this approach, but yeah, it's something we are working with the Makepad team in close collaboration. Of course, the framework is also focused on, as Rust offers, zero low overhead platform abstractions, very highly performance widgets, widgets like the basics of the elements of the user interface, buttons, label, text, blah, blah, blah. And the performance is an important thing. And I think that it's very important in products like Moxin because so far it's all test-based, but we are now presencing the rise of the models that produce image, speech to recognition, videos, and having a framework that make it easy and possible to implement visual things, charts, visualizations, data visualization. I mean, this is the next step for Moxin, to make more things that are more visual with the models, and having a framework that's efficient to implement in the user interface is very important. Of course, it's important for us, and Makepad tries to offer the rapid development cycle, good ergonomics to providing hot reloading because thanks to the DSL definitions. I will show you some examples right now. Let's pick a little bit of the code. I don't want to bore you a lot because this is more user interface. I know it's not But I hope that, for me, it's important that, especially for the community of people working on AI and the LLM models, that the user interfaces are becoming important, because we have to interact, we have to present the data, we have to model how the users can interact with the model. So working on good stuff or good frameworks and technology also for the UI, I think it's for the user interface is very important. Let's speak super quickly that we have. Let's try to just to visualize. I wanted to show you the specific code that happens in two situations. One is just to presentation is I call this bunch of information about the model a model car. It's just presenting information. We have some actions like when you click, you download a file. So let's see a little bit about the related code in Rust that implement that part of the screen. We have a model car file that represents that is called live design. You have a lot of declaration, and you have this is the more declarative style that you declare how your interface will look. Your use. I mean, it's a specific DSL for Maple, but yeah, you have the view. This is a heading. Sometimes you have a label for the model name, and you have to fill all the information. This is how it looks. You know, the data itself is how it looks, and you have more pieces like this one. The model card itself is the main widget. Let's say it's a custom widget. It's a widget that we built with all the primitive from Maple. And yeah, it's more declarative and using the declaration that we have above. I mean, it's split in different types of elements of the user interface. And this model card also has a Rust struct that has the same name, and there is a linking inside of Maple. Is the link between your definition of how it looks in the DSL and the Rust component that make it behavior, make it behave like it's supposed to do. So we have to implement some things that are part of Maple. In Maple, you have to implement as a minimum this handle event. It's just passing events through the nodes of that compose the thing in your interface. And here we have the routine, the function that you have to implement to draw it to the screen, actually. And this is more direct. I mean, this is the mix with the immediate mode that you have to be explicit on how to implement, what is going to draw there. Here we are grabbing the model information from the scope. It's just a way to pass a parameter to this component because it's going to be one card for each model in the listing. And for this label, for example, is the model name, is the one that you see in the DSL. Here is the final. This is the label with the model name identifier. So you can go there and actually set the text. That is actually happening in each time it needs to do a drawing. It's not happening all the time. It redraws only when it's needed. This is all handled by the platform. And this is the way you can fill up all the information. And the other interesting part is probably the events. You have some events here. This is a drawing. Here's the events, sorry. You have two buttons. One button is to see some files, but also we have an action that is when it's selected. But yeah, this is the way you can deal with events in the platform. I'm not going to be specific because it's going to take a lot of time, but yeah, you have the concept of action, which are events, which is pretty common in this kind of frameworks. We have the main application, which is where the glue happens. But probably the interesting part is the store. We are calling the store the piece of Rust that is communicating with the backend. We have all centralized there in one piece, in one module, sorry. And we have one reference to the backend where we send the commands. We use channels, basic Rust channel. We have a lot of the communication implemented with Rust channels. And I'm going to show you a few examples. And here we at the end of the day, this is a central place where your user UI code, the one that is implemented with Maple, is going to retrieve data. So we would use this storage struct like the point of contact with the backend where we get data, and also as a cache for things that we already have for the application. Let's show a little example is how we implement the chat command. The chat. We have the chat. Yeah, all it starts here. The chat is when I'm chatting. I mean, send a request to the models. We end up calling this function, send chat message. Actually, we have everything specific to the chat behavior in a dedicated place, but it's just in direction. And you can see here the way we are using channels. When we communicate with the backend, the backend in Rust is not an external backend, it's running locally. The computer, we call it backend because we were interested on architecture, doing an architecture, that was good enough in the future to expand. I mean, probably we can have that backend in another place in the future. Let's say if we want to implement this user interface in the web, probably that backend will be more backend in the web sense. But since this is an application, desktop application, we have the backend running locally. We create the sender and the channels is that primitive. I mean, this is more async programming in Rust, but yeah, this is one of the basics. It's not the most, it's the basic stuff that you have in Rust. You have more libraries and higher abstraction, but we are using just the basic of Rust. We do most of the communication with regular channels. So you have a sender and receiver. We issue that command, that is the command chat that we end up sending here at the backend. We send this chat command with a prompt, and it's part of the command, the sender. The sender, we create a channel with a sender that we are sending to the backend, so they have a way to send us the response, and we can do it all in an asynchronous way without stopping the user interface. We implement almost everything with that because we want our user interface to be as much responsible as possible. So we have a lot of working with threads and channels. We send these chat requests, and we create a thread that is actually responsible to start receiving the response, which is not happening in one step. The channel makes sense because we are going to stream token by token the generation. So you have that behavior that is super common in ChatGPT, that you see word by word the generation. So this thread is going to live in a loop, receiving chunks of the response. The chunks is generated with the WasmEdge, as Heide was explaining. We are explaining now how we use as a client, Rust client, all that information that is being generated by the piece of code that is closer to the model. And when everything is done, in fact, when we receive each message, it could be the completion, the final one, the streaming is done, or just the command to append delta, we say, because we receive one token and we want to form the whole response in one place. And this is a way, the signal to UI, this is part of Maple. This is a way that Maple offers to us to send a signal so Maple knows that there are some changes, because we are now in a different thread. We are not longer in the UI thread. So yeah, we need a way to do that. In the main application of Maple, which is the entry point of the whole application, you have a way to ask or to respond to the signal event. It's going to process that piece of information. This process to event signal here is going to actually receive the information from the data. Here, there is a lot of indirection, but you end up almost in the same place. And here you receive the specific chunk, and you update the internals information of the application. And that is reflected in the user interface because we have a draw routine that is super specific that draw what you have in the moment. Okay, let's probably, I don't know, I lost track of time. How much time I have?
You had 20 minutes.
20 minutes? Oh, I have a lot. Yeah. But let's do something more interesting, or let's do a little more of demo with Moxin. We are back here. So I want to present you, I mean, again, it will depend. I know how many people here is, I don't know, knows about prompt engineering. There is, yeah? And some people want to try or to learn, I mean, just to practice. Okay, I mean, I'm in that period. I mean, I kind of like it, and I all the time like experimenting. But I didn't study it in deep, so just trying to follow some blog posts or guides about that. But Moxin helps me to do that because I have one easy way to do that. So let me show one example I was preparing. No, escape from here. Let's put so let's say I'm gonna copy because I don't want to type a lot. You may notice that my English is not perfect, so I want to keep learning, especially weird or rare words, not the usual ones. Words from the literature. I cannot even pronounce that word fine, so bear with me. But yeah, so we have a Bennett, the moonlight, alone, Sylvan Force, darted through the trees, blah, blah, blah. Certainly, the rarest word in the sentence is Sylvan, which I tested that with ChatGPT, and that's the most uncommon or fancy word on the sentence. So I would say this model did a pretty good job. But what about if I test this one with I have, for example, this Mistral, which is not chat, it's intruct. I'm not sure if I understand the difference between instruct and chat. My understanding is that what I'm doing right now is more chatting rather than making instruction or describing a task. So I would expect that this model works better with instructions, but it's pretty good because it's actually the bigger and in theory the most capable model I have in my machine right now. If I have bigger one, my machine is going to struggle. But for example, here I have a one that is my smaller one. I could test smaller, but this is the smaller one I have. And sometimes, I mean, it's kind of weird. It's not so perfect. So one thing, I can see the differences between the things. But let's say now I want to, let's say I want to keep adding phrases. Actually, it's not carrying on the context. I'm not being very specific about that. I think the Llama one makes a good job catching up. But let's see. Remember that behind the scenes is using LlamaEdge. I mean, the thing that was presented by Haidai, which is fantastic. And then you have some definitions. It's fine. Let's see if I gave them. And now it's describing another weird, or it's highlighted some weird words on my new sentence, so I think it's fine. But let's say that I want to improve it a little bit, the format. I mean, I'm interested in having in a better formatting of my response, so I'm going to restart this one, saying that I want to be specific about the word and the meaning and using like a structure on the response. I mean, I want to tune how the response is going to look. It's not perfect in that sense. I would want to have a bit better on that. One thing I think this model should be a little better on that. Now, it's closer to what I have. But one thing I want to test a little more is to providing examples. I have read that providing examples is a way to help the model to improve the response. So let's give some examples and see what happens. Tends to improve. And that's the thing that, I mean, for me it's like a wow, because I'm just discovering these things, but having a quicker way to test these things for me is fantastic. Of course, I would like to save resources, and I would like a lot that smaller. I mean, I changed in architecture. I mean, Kiwi, Llama, I don't have idea. I have to better understand the underlying architecture, but yeah. And here it was pretty good, but if I retry, it's not going to be perfect. So I can conclude that for this task, that the bigger model is better. And I actually can find the hotspot between the size of the model. Let's say I later want to expose this like a web service, so I want to save resources at the end. So finding the right model that I have to tune is a good thing to do. One thing that I don't want to bore you a lot, but I produced this larger example. This is larger. This is larger because it has more examples. I mean, it has more examples. It should be better. I was using the bigger model to produce better results for having better examples. That was my strategy. And I found out that with a lot of examples, this model could behave a bit better. Also, I learned that if I go to Llama, which is more chat-based, I guess, with this, it's going to struggle a little bit. I mean, it's much better with my initial prompt rather with these examples, more elaborated. And now works pretty well in this example, but it tends to don't catch up a little bit. What about, let me do another final example. I'm going to cheat. I want to troll it a little bit. The cat is under the table. I mean, which is the unusual word here? No one. I mean, it's a cheater. I mean, I cheated him. This is the first. I mean, this is from learning English from when you're a kid. It's a super basic sentence with no weird or unknown words or rare words. It insists that under is the word that is difficult, which I don't think makes sense. This is because of the examples, right? I'm put a lot of precise instructions on the model in the prompt that actually is kind of forced to say something. But we could have more elaborated examples, so I end up doing something that is not perfect, but it's something like this one. Where is it? No. I have, you can try with more interactions. It's not going to, it sounds to work from time to time, but it's not perfect. I'm describing the task. I'm telling him to first to split the show in two parts, logical reasoning. The first one is try to think if there is some word that deserves to be called a rare word. And then it has permission to say me that I can't see any interesting word to explain. That's a valid response according to my instructions. And then actually, if there is a word that is worth to explain, it's going to do that. Actually, it didn't work here because the last sentence was on a hot day, the puppy panted on the cerulean sky. Cerulean is kind of a not common word in English. But I provided example. For example, this cat is under the table. I can't see anything interesting. So this is not always working. I have the feeling that I need a more powerful model to do that. That's my conclusion. But I can say the baby is sleeping. And woo! Worked. I mean, I'm not going to tell you, to lie you. I think this model or this prompt is not perfect. It has to be worked. But it was just the experiment you can start to do. And if you're like me, interested in this prompt engineering world, I think this kind of tools, Moxin in particular, is going to help you to navigate that part. So let's try to conclude this talk. Closing notes. What is the roadmap in the plan for Moxin? Because we have this little demo to present today, but we have plenty of work to do. And it's just an advanced premiere, but yeah. Some ideas that we have, let's say in the short term, go beyond plain text conversations. As I will already say, I already say that getting the most of Maple and the stack that we are using for the user interface, I was insisting a lot today, but yeah, we need to, we are pretty close to start doing things with images, video, chart. It's just a matter of working on the user interface. The user interface itself is going to be more complicated, but yeah, a problem for the designers and of course for the developers, but good problems. We want to integrate with the Cloud API. What was one of the questions that we have during the talk, that we are now interacting only with the models that you download, but we have everything in place to, we can speak and to send prompts to, the public API that are available in the world for LLMs models. Also, we want to implement the notion of different agents, so we can implement orchestration of things to accomplish complex tasks. I mean, different models, the different models interacting in a way. For example, from the example I just made, the demo, I have the feeling that we could have a model that is better detecting if you are using or not a rare word, and probably another model that is better explaining the word. I mean, that kind of combinations or the interaction that you have to organize the conversation and getting information from different sources and models is the thing that we want to, with Moxin, to provide an easy way, an approachable way, and a friendly way to test that flows. Of course, we want to be really multi-platform application. The desktop is what we have right now, but we want to explore working in the web version of this one. The user interface is going to work pretty well because of the Maple. It's already prepared to also have a deployment in the web, I mean, as a platform. But of course, we have to rework a little bit or adapt the architecture in order to respond some questions. Where are the models are going to run? I mean, if you have a web page serving this application, where are they running the models and these kind of things. We also have long-term goals for Moxin. We have the aim to, the big goal, the big aspiration to build an explorer for the AI. Again, you have Hugging Face, you have another things, but we dream to have this application like a hub for all this information, adding specific information, adding descriptions, more high-quality information about the models and the options that you have. Also, we want to engage with the social community. It will be fine, great, for example, enable the community to enrich our metadata about the models. We have to open ways to do that, and yeah, to foster more collaboration because it's all open source and collaborative. And also, this is a specific goal that we have. We also want to fully integrate with the federated matrix ecosystem. Under the Rubius initiative, we are also working on this being matrix client application. We have Kevin from that team, and there is plans to collaborate in that matter and to have one integrated solution that we can have the best of both worlds working together. So, my final words are reserved to say thank you for listening to me, but also to calling you to get involved. We need help by using the application. I invite you to try it out, to report issues, to write ideas, and to communicate with us about how this could be better, and if you have more ideas, and be involved. Also, I invite you to use the code. I mean, it's an example, it's a working example, real code, something that is real. As I already said, there are not a lot of examples of real application built with Rust. It's also a good example of an application, Rust code, that is a client of the Wasm LLMs engine. So you can just use the backend part of our front-end backend setup, for example. That will be interesting to be more people using at least part of our code, so we can improve it together. So, thanks. That's all. Thanks for listening to me.
Hey, any question for George and Haidai?